What is PWM? PWM stands for pulse width modulation. Normally, when we want to control the amount of power sent to a load, we reduce or increase the voltage sent. But doing this creates opportunity for heat loss, and when it's something we have to control from a microcontroller, it becomes impossible. Since the microcontroller can't just change the voltage level you can get from its pin just like that. If it has to do this, it does it through pulse width modulation, and this it does by switching the signal rapidly between the on and off states. But the load, instead of perceiving the 5 volts at turn on or the 0 volts at turn off, perceives the average voltage, which is dependent on how long the signal stays on compared to how long it stays off. We can find our average voltage with the help of the duty cycle, which is the fraction of time a signal is on compared to the total time for a cycle. Duty cycle equals on time divided by the total period multiplied by 100 and is represented in percentage. So our average voltage can be gotten by multiplying the duty cycle by the maximum voltage. So if you have a signal that is on for half of its cycle, it has a 50% duty cycle and carries half the power one will get for a 100% duty cycle. That is if the signal is always on. And we can implement all this with this Arduino code, which will be changing the brightness of an LED. Okay, so now we send this to our Arduino, okay, and we expect to have 100% brightness, alright, because this is 255 at 100% duty cycle. Okay, so let's try for 70% brightness. Okay, 70% of the highest brightness, which is 255, should be 178.5, but let's just give it 178. Alright, and let's see what we get. Okay, alright, we see what we have. Okay, so let's also try at 50% brightness, so that will be approximately 127. So let's do that. And we'll see what we have too. So why use gamma correction? First, it's important to note that human perception of brightness is not linear, and we perceive or we see changes in brightness at low intensity better than high intensities. So we apply gamma correction to make PWM controlled LEDs feel linear to our senses. The formula for gamma correction is out equal to round times in over max in raised to the power of gamma times max out, where in here represents the brightness level we generate from the program, and it's usually within the range of 0 to 255. A max underscore in represents the maximum possible input value. The gamma sign represents the gamma correction factor, which is approximately 2.2 in our case. Okay, it can be any number greater than 1, but since we're dealing with the human perception of brightness, 2.2 is an appropriate factor to use. Max out is the maximum output and is usually within the PWM range of 0 to 255, and then out is our corrected output, which we send to the LED. The in all over max in, okay, will give a value between 0 and 1 and will represent how bright we want our LED to be on a linear scale. Now, applying gamma, that's raising in over max in to the power of 2.2, adjusts the curve to fit human perception. Multiplying everything by max out brings us back to the 0 to 255 range used by our PWM. Rounding up everything helps us to get an integer value as our answer. Usually the gamma curve and the linear curve placed together will look like this, and for the gamma curve, each curve depends on the value of gamma you use. So implementing the gamma correction formula in C for the Arduino, we type Now, since input all over max in gives the value between 0 and 1, we add 0.0 to the maximum value, so the computer gives us floating values instead of integers, else it will output just zeros from the calculation. The input over 255.0 represents the input over max out. Alright, so UINT8_T corrected helps us store the result as an 8-bit unsigned integer. The function POW brackets open x, y bracket close raises x to the power of y. So used above as it is, it raises the input over 255.0 to the power of gamma. So in summary, we take the desired brightness scaled from the range 0 to 255 to 0 to 1. Then we apply the gamma curve, scaling it back to the range 0 to 255, rounding it to the nearest integer, and then storing it as the gamma corrected pulse width modulated value. And then we send the signal of the translated duty cycle to the LED. Okay, so let's send this to the Arduino and see what happens. Alright, so if we compile and send, if we compile and upload, alright, it's done. We see that's 100% brightness. Alright, if we bring it down to 70% brightness, we'll have 178 for 70% brightness. Uploading sketch, and we have that. You see, we can notice the difference between 70% and 100%, okay, which wasn't the case without gamma correction. So let's try for 50% brightness. 50% of 255 is 127. We upload sketch, and we have this, alright, which is very different too from the 70%. So you see, with gamma correction we can perceive the change in higher levels of brightness better.